Hi guys, hope you all are doing well. Today we are here to just progress our kinetic theory of gases, and today's video is going to be a very short video. You can just relax, and just three topics we are going to cover here. Before we begin, there are three topics. One is diathermanous substances, Athermanous substances, and perfect black body. So these are the three topics we are going to discuss in today's video. It's just going to be a very easy walkthrough, and these are basically just theoretical part, no derivations involved. Before we start, in case you haven't subscribed my channel, then kindly do so, and let me know what kind of videos would you like to have a see at. So without wasting any time, let us begin with something called as diathermanous substance, which you can see already on your screen. Diathermanous substances, I have written the definition: a substance through which heat radiation can pass. That means it is not going to absorb, it is not going to reflect. In which heat radiation can pass is known as diathermanous substances. So a substance in which heat radiation can just pass. It's like if we have a substance, and if the heat radiation is incident on it and the heat radiation is coming out of it, there is no reflection and there is no absorption, then such a substance is called as diathermanous substances. So examples of diathermanous substances are glass, quartz is a kind of a crystal, sodium chloride is your common salt. So all these substances are diathermanous substances. They do not absorb, they do not reflect heat. Most of the heat radiations is going to get transmitted. So the value for transmission, coefficient of transmission, is higher in such kind of substances. However, absorption and reflections are pretty low or basically negligible. Now we come to athermanous substances. So just the opposite of diathermanous substances. So if you see, athermanous substances would be substances which are largely, just focus on, okay. So athermanous substances are those substances which are largely opaque. Opaque means basically they are not going to transmit, they are either going to absorb or reflect. So substances which are largely opaque to thermal radiations, that is, they do not transmit heat radiations. So in diathermanous substances it can pass, and in athermanous substances they do not transmit heat radiations on which are incident on them, are called as athermanous substances. So substances which are largely opaque to thermal radiations, that is, they do not transmit heat radiations, are called as athermanous substances. So there are certain examples over here: wood, water, iron, copper. These are substances which do not absorb, which do not reflect. These substances which are opaque to transmission, they do not transmit heat energy. So if I have a athermanous substance, if the heat energy is incident, either they are going to absorb or either they are going to reflect, but they are not going to transmit. So if the transmission coefficient is 0 or near to 0, then we can say the substance is called as a athermanous substance. So athermanous substance is a substance which is largely opaque, they do not transmit heat energy. So such substances are called as athermanous substances. Okay. Then we come to something called as perfectly black body. So if you can see on the screen, a perfectly black body. So a perfectly black body is a body which absorbs all heat radiations incident on it, is called as a perfectly black body. So a perfectly black body is a one who is going to absorb all the radiation. So if I have a perfectly black body, suppose there is a body, and if I incident some heat energy incident on this body, then it is going to absorb 100% of heat energy, and the such a body is called as a perfectly black. So it is not going to reflect, it is not going to transmit. That's why for a perfectly black body, the coefficient of absorption and the coefficient of reflection and the coefficient of transmission will have such values. A ka value would be 1, coefficient of reflection would be going to 0, and coefficient of transmission is also going to 0, because whatever the heat energy is incident on the body, totally it is going to absorb, nothing is going to get reflected, nothing is going to get transmitted, everything is going to get absorbed. And for a perfectly black body, perfect black body does not exist. So in practical, in real world, we can say that a perfectly black body does not exist in nature, because however black that body is, how much ever property you put into that kind of body, it is not going to reflect 0, it is not going to transmit 0. There will be some amount of coefficient of transmission and coefficient of reflection. So yes, A ka value would be very near to 1, but yes, it may be slightly less than 1, and if it is slightly less than 1, that means the body is not perfect. So perfectly black body in nature does not exist. And the second last point is lamp black. Lamp black is basically the black carbon which we get after burning something. So lamp black is taken as a perfectly black body for all practical purposes. So for practical purposes, we consider lamp black as perfectly black because it absorbs 98% of heat radiations incident on it. So because it is absorbing 98% of heat radiation, we can say that the lamp black is perfectly black body for practical purposes. But however, it is losing 2% of heat energy to reflection and transmission. So this is what perfectly black body is. This is what diathermanous and athermanous substances concept is. So today we have just met for understanding all these three. So in case you have understood and if you are following this lecture series, then please do subscribe the channel and keep posted yourself on the channel, and you'll have daily new videos going forward with the topic. This topic is about to end, so like 2-3 more videos and probably this topic is going to end. Okay, so thank you so much. Bye.